Hello guys, welcome to my channel and let me introduce myself first. So my name is Anna Goel and I am from Triple Sonipat in third year doing BTech in CSC. So without any much further delays, let's start with the question. So the question is from codeforces and it's cellular network and I am too much excited to explain you this question. The reasons are like first of all the video will be quite long because the question has three approaches and you will learn to like you will learn more much and more and one of the approaches mine and the two approaches are from editorials and the excitement reason is also that I have tried to solve this question a year ago and was not able to do, but now I have solved this question by my own method, so that's the reasons I am excited to explain you to you so that you can get also the three approaches how can we solve this problem. So without any much further delays, let's read the question. So we have endpoints on the straight line, the position x coordinates of the cities, and endpoints in the same line, the position x coordinates of cellular towers. All towers work in the same way. They provide cellular network for all cities which are located at a distance which is no more than r from the tower. Our task is to do is to find minimum R that each city has provided by cellular network. That is for each city there is at least one cellular network at a distance which is not more than R. So if R equal to 0, then a tower provides a network only for the point where it is located. Only a tower can provide a network for any number of cities. But all these cities must be at distance which is no more than R from this tower. So, so, so what the question is saying, we have n cities and m towers, and each tower has range, some range that like they provide a network that they make a network such that each city can get a cellular network at all. Can get a cellular network. Let's suppose there is a tower and there is some R that is the it has a fixed radius that is R. Then all of the cities that comes lesser than or equal to R will get the cellular network, and those cities that doesn't comes in that will not get a will not get the cellular network at all. So our task is to find out like with what is the minimal R such that all the cities can get a cellular network. So I hope you get what the question is saying. So there is some input that is n and m, then all the element that is a1 to an and b1 to bm, and the coordinates, and both of that is this one and this one, they both of them are sorted. That is non-decreasing order. So let's start with the question then. Okay, wait a second, just yeah. So uh, we have some array A and array B. Its size is n and its size is some, and there is some straight line. And let's suppose there one is A1 and here is B1 and here is some A2, A3, uh, B2 and some B3. Okay. So this one is the tower and this one is the city. This one is the city, city, and this one is the tower, or tower. So what is that? Like there is some range. Like let's suppose this is the range. So this is R. So we need to find out the minimal R such that the cities can get the cellular network at all. So A1 and A2 can get a cellular network. That is, if R is such that A1 and A2 can get the cellular network, and from B2 tower, then A2 and A3 can get the like can get a cellular network. The A2 and A3 city, and same with B3. Like It is not necessary that from each tower that all cities can get a cellular network, but like maybe or maybe not. I mean, what I mean by that, from B3, let us suppose there is no cities that can get the cell network at all. But from B1 and B2, uh, cities can get the cell network. So our main task is that each if each cities can get cell network at all, so we need to find the minimal R. So what can be the brute force? What can be the brute force? So let us suppose A1, A2, A3, and AN, and B1, B2, up to BN. So what is the brute force that we can think? So base we construct an array. Okay. So we will find out the distance, that is B1 minus A1, that is absolute difference, and say B2 minus A1, that is we will iterate all over 2n. So we will like B2 minus A1, we will do like we will store it up. Okay, so B3 minus A1 up to Bn minus A. Then again for B2 tower, we will do the same thing, that is B2 minus 7, and we will store the minimum value, the minimum of both of them. And then whole thing we will do, and the minimum value will be stored at here, at this index, at this index, and we have construct of our array. So after constructing our array, then we will iterate and find out the maximum value, and the maximum value will be our R, that is the minimum that we can do. So this will be cost us around order of n into m, and it will be 10 to the power 10. Since we know that the safer limit to not get really in online such rounds, in online such platform is 10 to the power minimum to minimum 10 to the power 8. That is, we can go to wait. That is, we can go to order of n, or order of m, or order of n plus m, or in logarithmic way, but not order of not n square, not at all. So since brute force is not the best approach to do this problem, like not an optimized way, okay. So what should we think? So first of all, let me tell you my approach. And before that, I will request you to I would like you to get a knowledge about binary search. Then then it will be easier for you to think like how we can do this question with binary search. Okay, since my approach uses binary search. So what I'm doing is like uh, we have some like I've drawn something, and we know that the radius is maximum can be all about 2 into 10 to the power 9, and the minimum radius can be about 0. So 0 to 10, 2 into 10 to the power 9, the value will definitely lie at here. We know this thing. Okay, we know this thing. So let us suppose that this is the R value that we are trying to find out. That is the minimum value. Okay, so from this tower, let's suppose this is the minimum value, and then this there. Okay, but we know that if R satisfies all the properties that we have to do, then R plus one also be the best thing that R plus one will also do. R plus 2 will also do, up to 2 into 10 to the power 9 will also do. But R minus 1 will not do this. R minus 2 will not do this. Up to 0 will not do this. This means that this part is not gives a answer, but this whole part is the will give us the answer. And R is the minimum one. So this from there we can get our intuition, that is binary search. So I am applying binary search on the radius. So what we are doing is the maximum value that we know is 20 to 10 to the power 9, and we have taken the mid that is 1 to 10 to the power 9, and we have that array that is A1 up to AN, and B1, B2 up to BN, and we will then check like if this is the radius. Then we are taking two pointers. Yeah. Also, you need to know about what is two pointers. Like you can practice some questions, and that the question will be way more easier. So we will take two pointers uh, from A1 and B1. So like is we will then take the absolute value that is A1 minus B1 is less than the mid value that is, let us suppose we give this as R. So is less than or equal to R or no? If this, then we will then just move to the next city, that is uh, L plus plus. And again, we will check is A2 minus B1 the same conditions. And let us suppose this one is not one. Then we will move our that is our sorry, we will move from this to B2 to B2 tower. Then we will again check, and after whole things and all over the condition that we will apply. Then after that, if L, that is this one, is equal to N, that means all cities has been covered. So this is the, so R is our, let R satisfies. Like R is the our answer, can be the answer. So then we will change our mid to, then we will change our mid, that is from 1 into from 1 to 10 to the power 9, so 0 to 10 to the power, that is 1 from 0 to 1 into 10 to the power 9, the mid value, that is 5 into 10 to the power 8 will be our mid value. So again we will check for this. Then the same process will continues, and we will get our minimal R, that is order of n into logarithmic of n. So this is how I approach this problem. In terms of R, I have binary search. So this one is my program, like code that I've done. So we will take n and m, and then total distance, that is 2 into 12, 2 into 10 to the power 9. Then we will take V1 and V2, then LLHP, that is starting position, and the last, that is 2 into 10 to the power 9, that is 0 to 2 into 10 to the power 9, the value is 11. Then ANS, that is the minimal R that we have to find out. So we will apply binary search, and L equal to 0 and R equal to 0, that is the two pointers. So if absolute value, like this condition that we apply, and then L plus plus and then R plus plus, if L equal to N, then ANS equal to mid, then the binary search, that code, that algorithm that we are just like putting it down, that paste it up. We are just pasting out. So see, we will just then see out ANS. Yeah, you can see that fixed size and fixed binary search update, because I don't know like where I was doing issues, so I just put it in ChatGPT, and then logic was same, but some code issues I've done. So that's why you can see that these comments. So this is what I've approached for this question, and let me tell you like what the editorials are for, like what the editorial approach for this question. Wait, where did I found both of them? Wait, wait a second, just I think uh, okay. Yeah. So first of all, this one. Second approach. So what is the second approach is saying? It's just saying that uh, like we know that every city must be covered. Every city must be covered. That is, A1 has to be covered, like in a coverage range. So we will do, like what is the minimal, like what is the minimal distance the tower is present from that city. That is B1 and B2. A1 lies in between. Then which one is the minimal of both of them? That minimal distance from both of them. That is, we will do like B1 minus A1 and then B2 minus A1. That is absolute distance that we will take. And which one is the minimum will be the minimal distance coverage range for A1 to be needed. So if we found for A1, then we will do same with A2. That is the closest tower for both of for the city for A2. Then up to AN we will do. And you may think like it will be around order of n into m, but no, because we will search it we will use binary search. Like A1, let's suppose is 3, and this one is 2, 5, 6, 7, 8. That is towers coordinates. So we will do binary search. We find out that it lies in between both of them. Then we will take the difference, and it comes out to be 1, the million distance. Then the same we will do, and then after all, we will check the maximum value, and that will be our. So this one is the binary search on M. And sorry, I have done this. It's actually or n into or log of r. That is the distance. That is 20 power 2 into 10 to the power 9. And this one is order of n into logarithm of m. We will do this problem. And I would like you to do the code by your own. Okay. So what is the third approach? And the third approach is really interesting because since there is logarithmic part that we are doing so far, what if what if it is done in a linear way? That is order of n plus n. So what? So first of all, you need to know about two things. The first thing is like if C1 is a city and C2 is a city and there is power present at here. So what we will do is not to find out like the network range. We will like to find out for C2, not for C1. And the same thing is like T1 and then C1 and then C2 and then C2. We know that T2 is much cooler than C2. Then rather than for T1 to find out for C2, we will not with T1 tower to find the coverage range, that is distance. We will then change our pointer to T2 to find out the distance from C2. That is the distance from C2. From wait, what I mean by that. Let us suppose there is C1. There is a coordinate axis and C1 presented here, C2 presented here, and there is some tower T1. So, would you like to find like for C1 distance from C1 to T1? Would you like to find out if we can if there's some T2 tower and which is much closer than C1? Would you like to find out for T1 to T1 distance like the coverage range? No, not at all. The C2 because C2 is much closer than T1. So of course C2 will be gives is much closer. So we will find out for C2. The same thing is like if there's T1 tower and there's T2 tower and then there is C1. So from where you will find out the minimal coverage range, that is R, from T2, not from T1, because it will of course increase the value. So this is the main thing that the question is trying to tell, like in order of linear time that we can do. So same here, two pointers approach will be used. Like we have A1, we have A2, we have A3, we have up to AN, we have P1, we have P2, we have P3 up to BN. So what we will do is to construct an array, and then we will do like here a pointer. Let's name it as L, and let's name this as R. So what we will do is to take the if like there is a condition that we will use that uh, if B1 plus 1, like is B2 closer than A1, or is your uh, B1 closer than A1? That means in a coordinate axis way, in a axis way, that is B1, B2, and then and then your and then your A1. So we will check like is B2 closer than A1 or B1 closer than A1. That is the absolute difference that we'll take. If B1 closer than A1, then we will like uh, take the difference of both of them, and then we will move to A2. That is L plus plus. That here will be our L, and the same thing that we find out, and we again get the same situation that that A2 is much closer than B1. Okay, so this one is our L that moves to there, and then we find out that B2 is much closer than A3. Then we will just do L plus plus, and same thing that we will do, and then overall we will find out the maximum distance of that all that we have calculated. But here is a catch too. Like what if uh wait a second, A1, A2, B1, wait, B2 and then B1. Like from B1 to A1, and like what I was earlier thinking, uh, like no, that is not a catch. But what was I was thinking, like from B1 minus A1, like wait, again I went down. Like wait, what was what I was thinking, like A1 at here and A1 at here. Like B2 is close, like B2 is from B1, it is in increasing order. I think I should not go with this. Yeah, I should not go with this. So this is the overall that we will do, like maximum of P1 and this whole thing that we will do, and this will be our minimal. So this one will be order of n plus m, since we are using two pointers, and L will be increased when we have covered this city, and R will be increased when if the tower is which tower is closer than that city. So for that we will do R plus plus. So let's come to the core part then for this one. So again in 10M, then we will take and then vector initialize and put the values, and ns equal to 0 and r equal to 0. So for int I equal to 0 to that is L equal to 0, that is that city pointer that points to a city, and while r plus 1, that is the same, like r plus 1 should be less than n, otherwise it will be like out of bound it will go, then absolute value of this is lesser than that, like the r that is uh, wait, what is it doing, like what this part is doing, condition is doing, it is just checking like wait, it's just checking like p1 minus a1 is lesser than or no, that's p2 minus a1. If this one is lesser, then let R be at here. Else you will do R plus one plus so that you will be at B2 tower to get the minimal for that. So if that's so R do R plus plus until you find out the optimal distance, then ANS equal to maximum of uh, ANS and absolute value of both of the tips distance. Then we will see out ANS. I hope you get all those three approaches. And if you have any doubts, so put that in the comment and I will explain it. So I will explain it too. And that's from my side and bye.